Hello. In this short video, I'm going to give you a very informal introduction to my idea for advanced water electrolysis. My name is Martin Jones. I'm a citizen of the United States of America, and I'm making this video at the request of Dan Winter to explain to you my idea. So, electrolysis, what is it? What are we trying to do? We're trying to break the bonds between the oxygen and hydrogen in the water molecule, H2O. So water molecules have three vibrational modes. They have the antisymmetric, symmetric stretching, antisymmetric stretching, and the bending modes, all that occur at a vibrational frequency in the terahertz range. Now, ideally, to break the bonds, we'd like to excite the molecules at their resonant frequencies in that terahertz range, with a laser or something like that. Um, and that was an original idea that I had, which still could work. But I'm explaining to you now how to use heterodyning to effectively excite the water molecules at a subharmonic of their vibrational frequencies. There are two ways to do it, so far as I can tell. You can have just a regular water capacitor and oscillate a potential with a square wave, and I believe a square wave is most efficient, but you could try sine waves, and oscillate a potential across a water capacitor, a capacitor where water is the dielectric, at a subharmonic of the terahertz values. I think that's what has been done in the past by people like, the people that have done it. I can't recall the names right now. But they have these values, that were supposed to be the resonant frequencies of water as a whole. Okay. Well, I think they're finding critical subharmonics of the terahertz values of the vibrational modes of the individual water molecule. Now, you may be asking about microclusters. There are microclusters in the water molecule. In the water. Yes, this idea works best with smaller microclusters. The smaller, the better. In effect, a lower surface tension of the water. So that's important, but it's not necessary because there's studies that have shown that certain electric fields will stretch the microclusters out and essentially line them up to do exactly what we want to do, vibrate their, I believe, symmetric stretching modes, and excite those modes, and then eventually at the resonant frequency and eventually break them apart. Okay, so that's one way. The other way, which I would like to try, is the RLC water capacitor circuit. It's actually a RLC circuit where the capacitor is a water capacitor. The RLC circuit is good because you can design it for a very high resonant frequency. The closer you can get to that terahertz value, which can be found on the NIST website for water molecule, the higher the better, as you know. So you can design and RLC circuits all have resonant frequencies that they can be designed to run at, and the RLC so you can design it for a very high frequency within reason that your equipment can allow, which would be a very high subharmonic of the resonant stretching modes of the water molecule itself. Now, This is good because you can design it for a high resonant frequency and run the RLC circuit at even a lower frequency, a subharmonic of the subharmonic. So in effect, you're heterodyning to the terahertz value that you want. That may be expensive, high-powered, high-wattage lasers you can't afford right now. So I'd like to try this. Now, just as an aside, Whittaker in 1903 wrote a paper that essentially proved that the electric potential, is a sum of waves. It is a sum of waves. So essentially, what I think is happening in regular electrolysis is that they are doing precisely this in a very inefficient manner. That's why they're only getting a very small percentage of hydrogen from the water, a small percentage of hydrogen and oxygen, twice as much oxygen than hydrogen, because the potential, even a DC potential, has a wave nature, and they are exciting water molecule modes, and I believe that those waves have higher frequencies at higher voltages, DC voltages. Now, what I've explained to you before already about the RLC circuit or the water capacitor, just straight potential, I would think you would need a square wave, AC square wave. That would be the most efficient. But I think that regular electrolysis is doing this exact thing. There's no chemical reaction happening at the cathode and anode. I come to this conclusion because I've designed a spreadsheet that designs for the current needed, the voltage needed, the area of the capacitor plates, and the distance between them. And for some inductances that you choose in this spreadsheet, you get areas of the parallel plate capacitors that are so small that they could be two wires or two nodes, electrodes, a cathode and an anode. So I think that is what is happening in regular electrolysis. Just a theory, but that's an aside from the main topic. So let's try this RLC circuit. Could be exciting, could be profitable, and I'd love to work with it on it with you, whoever watches this. Thank you.